Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So once again, I am welcoming you all to this platform. Now, I am happy to announce that now we are going to providing online training for GATE and engineering service exams. Now here your classes are taken care by India's top educators who are toppers from IIT, okay, toppers in GATE exam, toppers in IES, okay, they are the and well experienced faculty. They are the team is going to handling the subjects in Unacademy. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, here we check how to get Unacademy learning app into your device first. Just go to Play Store, type Unacademy, then it will shows the Unacademy learning app like this. It will shows the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. Now, what you will get? So by joining Unacademy, what you will get? First of all, you have a daily live classes. Every day you have a live class. The intention to conduct a live class and every day is always to keep the student in touch with the subject. That is the intention behind that. And in that live class, you can chat with your educator. That means you can chat with your faculty, engage in discussions, and you can ask your doubts and answer polls. So you can perform all these things while class is going on. Okay, you can perform all these things while class is going on. Next one, structured courses. The next thing is structured courses. Here, all our courses are structured in line with your exam syllabus. So whatever the course you are going to be preparing, that course is well structured with your exam syllabus. Then you can save the time. No need to check for which topic is there, which topic is in syllabus, which topic is not in syllabus. Okay, and they will arrange those things in a proper order. It means first which topic we need to complete or which subject, after that which subject, after that which subject, like that. That information you can store in that, place properly in that. Then it is very easy to the students to understand the things and to complete their preparation. Now, next one is live tests and quizzes. It is very important thing. Once you feel that your preparation is completed, your next step is to evaluate your preparation, the topic. You need to write more number of tests and quizzes you need to attend. So you can do that one here. So you can evaluate your preparation, with our regular mock tests and quizzes, and get detailed analysis on your performance, Okay, after writing the exam mock tests and quizzes, we are going to give the detailed analysis on your performance. If your performance is good in that topic or in that subject, then you can give less priority to that and you give high priority to the remaining subjects. Okay, and after that, unlimited access. What it means is, see, once you taken a subscription, once you taken one subscription, you can get your access to all our live and recorded courses. That means whatever the content available in your app, it is either live class or recorded course or recorded class, you can directly access that once you take in a subscription. Number of times you can see that one, not only limited time, 1 hour, 2 hour, 3 hours, not like that, once, twice, thrice, number of times, multiple times you can go through that. Okay, and you can watch from the comfort of any of your device. Serious. So you can take any of your device, choice is yours, tab, mobile, laptop, desktop, whatever the thing you have. So you can view the class in that one. That comfortability we are providing. Okay, these are the things you get by taking the Unacademy subscription, basic subscription, that too. Now there are two subscriptions, iconic subscription and plus subscription. In plus subscription, see, plus subscription is the basic subscription. What are the things just before I explained? During plus subscription you get those things: daily live classes, structured courses, live tests and quizzes, unlimited access. You get all these things in plus subscription. You get all these things in plus subscription. Okay, after that, next one, iconic subscription. In iconic subscription, what the benefits, what are the benefits got by the plus subscriber? You get all these benefits. What are the benefits got by the plus subscriber? You get all these benefits. In addition to this, you are getting few more. These are the additional benefits you are getting in iconic subscription with respect to plus subscriber. First one is personal coach. So you can get one-on-one guidance from top exam experts as your personal coach. Okay, top exam expert. We are assigning the top exam expert to you. He is acting as a personal coach to you. Once you've written some exam or you attempted some test or some quiz, he is going to analyze that. Based on the analysis report, they will prepare proper study plan to you, and respective study material also they will provide to you. Okay, respective study material also they will provide. These are the benefits you got from personal coach. At the same time, study tracker. Here, to evaluate your progress, to know your progress, by participating in study tracker plan and study booster workshops, you can evaluate your progress in bi-weekly reviews with personal coach. Yeah, here also your personal coach plays an important role. Where you are, where is your preparation, what is your progress? You can get that complete information through study tracker. You can also, here you are reviewing with your personal coach. And next, mains question and answer practice. Yeah, this is very, very important. Students who are preparing for the engineering service exams, in that exam they need to write the descriptive questions. They need to answer the descriptive questions. Okay, so in that case, you can strengthen your mains answer writing through regular practice. You need a regular practice, and after that we are going to evaluating your questions, what you are writing, and we give the personalized feedback to you. Okay, from that feedback you can strengthen your mains answer writing capability. Okay, these are the additional things you are getting in iconic subscription compared to plus subscriber. Okay, so what are the benefits got by the plus subscriber? You are getting all these benefits. In addition to this, you got personal coach, study tracker, mains question and answer practice. These are the things you are getting here. Okay, next. Plus subscription already we discussed. Next one. Yeah, in this month, today, there is a GATE Achiever Summit going on. Okay, so now it is free to attend. Now attend this, don't miss it, and you can discuss, you can share their views and you can share their experience, because already they are success in their examinations, and get the more benefit and mostly get the more information from them. Okay, so this is very useful to you, don't miss this. Now, so our today's topic is a common gate amplifier, analysis of common gate amplifier. Here, so now we are going to common gate amplifier. Common gate amplifier. Okay. Now, first I am taking the circuit diagram. So in circuit diagram, first I am taking the properly biased JFET. Properly biased JFET. Okay. So this is our JFET. So this is a properly biased JFET. Properly biased JFET. It is R1, R2, RD and RS. Means this is the drain terminal. It is the drain terminal, source terminal, and it is the gate terminal. Okay, so this is properly biased FET. So you are saying common gate amplifier. So that means the capacitor is connected to ground from gate terminal. This is CG. Now it is common gate. So now after that, taking output at drain through capacitor. This is CD. And after that, taking input or giving input at source. This is input. This is CS. Okay. This is the circuit diagram of common gate amplifier. circuit diagram of common gate amplifier. Okay, now we need to take AC equivalent circuit of this. AC equivalent circuit of this. To get the AC equivalent, first we need to take the series. Here I am going to copying the circuit because we need to apply different steps on this to get the AC equivalent. Next. Now I am going to applying AC equivalent circuit. AC equivalent. For AC equivalent circuit, step 1 is all external capacitors are short circuited. Capacitors are short circuited. Now I am short circuiting. So short circuiting this and short circuiting this as well as this. Now drain directly connected to V output, source directly connected to V input. Now gate terminal directly connected to ground. Okay, that is the step 1. Now step 2 is so just before we got gate connected to ground, drain we are taking output, at source you are applying input. Okay, now I am going to step 2. Step 2 is external DC voltage, that means all DC voltage or VDD is connected to ground. VDD is connected to ground. Connected to ground. Now I am doing that. So this is simply connected to ground. It is also connecting to ground. Okay, now here R1 parallel with R2. R1 parallel with R2. And even though it is parallel, because of short circuiting of the ground, gate to ground, no use of these two resistors. Simply you can connect gate to ground. Now the EC equivalent circuit is next level of equivalent circuit is like this. Now this is the gate terminal. It is source and it is a drain. Okay, now external connections are gate connected to ground, after that source connected to ground through RS, now drain connected to ground through RD. Now at a drain you are taking output and at source we are applying input. This is the equivalent circuit, AC equivalent circuit of common gate amplifier. Okay, now I am copying this for reference purpose. Now I am going to replacing JFET by, it's a small signal equivalent. Okay, this is our JFET. Now CG, common gate amplifier. Now small signal equivalent, I am replacing it by JFET by. First I am writing small signal equivalent. Small signal equivalent of FET. Small signal equivalent of FET. Okay, here this is the small signal equivalent. It is the source, gate. Between gate to source we have voltage VGS, and it is like this. This is the drain. Drain current is ID. Gate current is 0. Because of that it is open circuited. And this is GMVGS. It is a RD or RDS, small RDS. It is VDS. So your RD is represented by sometimes small RDS, sometimes it is a R0, small R0. Okay, so any one of the form you can use. Clear? Next one. Now here I'm going to replacing this JFET by this small signal equivalent. Okay, now I'm taking this one, I'm going to giving the connecting these additional things to this. Okay, now see this. In previous circuit, what we have is, see your gate connected to ground, drain connected to ground through capital RD, and source connected to ground through RS. And to drain you are taking output. This is ID and this is minus ID. And at source terminal you are giving input, V input. Okay, this is the next level of equivalent circuit. Now anyway we know that gate is common to both source and drain. Now I'm going to, this is a rearranging like this. So gate is at input side, source is at mid, drain is at output side. Drain is at like correct position, but source and gate are different positions. Okay, but connections are good, but for seems to be somewhat different. Now I'm going to rearranging like this. Gate, source, I'm going to be interchanging. That means changing their locations, and the circuit also changing according to that. Okay, now so it is like this. So first of all, it is a common gate. Gate is going to be taken to common. Is a common gate. Gate is taken to common. This is gate terminal. It is gate. So gate is connected to ground. At input side we have a source. Input side we have a source. Okay. Here we have drain. Now if you observe this, between source to drain we have GMVGS and RD. Now it is like this. So like this. See this. Source to drain we have GMVGS and RD. It is GMVGS and it is RD. Okay. And between source to and drain to gate we have capital RD, drain resistance. Between gate to source to gate we have RS, and here you are connecting input and here you are taking output. So this is ID, this is minus ID, and this is the voltage VDG, output voltage. So this is ID and this is a minus ID. This is ID. This current is a ID minus GMVGS. This is ID. ID is coming. Just apply KCL. ID entering, GMVGS leaving this side. Now the remaining current this side is ID minus GMVGS. Okay. This is the final equivalent circuit. Now we are working on this circuit. Okay, this is your input voltage, and at the same time here we have a voltage between gate to source we have, that is small VGS. Now we are saying it is VGS, now it is V input. Therefore the first step is V input is nothing but a minus VGS. V input is minus VGS. Okay. Now first I am going to calculating input impedance of this circuit. Okay. So for that, first I am copying this. See this. Now we need input impedance. Okay, this is the input impedance, input voltage by input current, Ri. So which is input voltage by, that means input current. So here you get Ri dash, which is Ri parallel with Rs. Because whatever the voltage here and here voltage same, that's why I'm taking V input. Now it is minus VGS by minus ID. Okay, or better to, we keep V input as usual, V input by minus ID. This is my requirement. See this. For that what I am doing is, just I am going to applying KVL to this loop. Applying KVL to this loop. Okay. So applying KVL. By applying KVL, we can write V input is equal to is minus VGS is equal to minus of ID minus GMVGS into small rd plus minus ID into capital RD. Okay, now it is here it is a plus GM into minus VGS, which is V input we can write. Therefore, V input is, it is minus ID and it is minus ID. So, minus ID times small rd plus capital RD, small rd plus capital RD, minus into minus plus. Okay, and or you can write minus GM into VGS is minus V input already we taken into small rd. So I am simplifying this. Therefore, take this one this side, V input plus GM into RD into V input is equal to ID into small rd plus capital RD. Therefore, V input into 1 plus GM into RD equal to ID times small rd plus capital RD. Therefore, V input by, sorry, it is minus ID. Minus ID equal to 1 plus GM into RD by small rd plus capital RD. Okay. Now, in this, see this here, this is nothing but your input impedance. Therefore, input impedance is Ri is V input by minus ID, which is, you can take this is approximately GM into RD by this is also smaller RD. Just a minute. V input by RD. Sorry. Here V input by R minus ID is 1 plus GM into small rd. Here it is a small rd plus capital RD. And one more thing, here small rd is much greater than capital RD, as well as GM into RD is amplification factor mu, which is much greater than 1. So from this we can write small rd plus capital RD can be written as approximately small rd. From this we can write 1 plus GM into small rd can be written as GM into RD. Now I am substituting these things in this. Therefore, your Ri is V input by minus ID equal to small rd plus capital RD can be written as small rd by 1 plus GM RD is written as GM into RD. Now RD gets cancelled, therefore which is 1 by GM, that is the input impedance. And here you can take Ri dash, effective input impedance, that is the required one. Ri dash is effective input impedance, which is Ri parallel with Rs. It means 1 by GM parallel with Rs. That's it. That is the input impedance. Okay. Now, next we go and calculate current gain and all this. So I'm going to copying this. So as usual, we are going to calculating current gain, because for common gate source and common drain, current gain is 0 infinity because of Ig 0. Input terminal is gate 0. Input terminal is a gate and its gate current is 0 because of that. But in this case, input is source, output is drain. So this is the input current, this is the load current. Therefore current gain AI is minus Id by minus Id, which is 1. Current gain is 1. Okay, current gain is 1. So it can be used as a buffer, current buffer. Okay, so after that I'm going to calculating voltage gain. Voltage gain AV. So voltage gain is simply output voltage by input voltage. So we know that this is your output voltage. Okay, now its output voltage is simple, minus Id into capital RD. Now I am substituting that, minus Id into capital RD by V input. See, just before we derived an equation V input by minus Id, RD plus RD by small rd plus capital RD by 1 plus GM into small rd. I am going to using this relation. So we know V input by minus Id is small rd plus capital RD by 1 plus GM into small rd. Now I am using this. Okay. So therefore voltage gain is minus Id into V input into capital RD. Now minus Id by V input is, from this I am writing 1 plus GM RD by RD plus capital RD, which is 1 plus GM into small rd by capital RD plus small rd into capital RD. This is the voltage gain, exact value. Now I am taking assumptions. Okay, see, we know that GM, just before we written 1 plus GM into small rd is approximately GM into RD. By applying this one here, it became approximately GM into small rd into capital RD by small rd plus capital RD, which is equal to GM times small rd parallel with capital RD. Okay, next level also you can take small rd parallel with capital RD is approximately capital RD, and therefore voltage gain is approximately GM into capital RD. Okay, so next I am going to calculating output impedance or not. So for this output impedance, what we have to do is, whatever the load we have at external output side, drain side, I am going to disconnecting that, and whatever the source terminal we have, that source terminal side input voltage what you connected, the input, I am going to taking that one to ground. This is gate. So this is small d, this is id, this is vdg. Now your output resistance R0 is vdg by id at v input equal to 0, because already output is RL, whatever the RD we have, we disconnected that RD. Now once input, sorry, one more, here we have RS now, and it is VGS. V input is 0, simply short circuiting this, short circuiting this. Once we short circuit this, now VGS equal to 0, and here we have RD, this current is GMVGS. Now the current through this one is ID minus GMVGS. Okay, now, so once when input equal to 0, V input equal to 0, from this VGS also 0. Okay, now applying KVL to output loop. Therefore, VDG equal to ID minus GMVGS into RD plus voltage between these 2 points is 0, because this is grounded, 0. But at the same time, VGS equal to 0, this value is 0. Therefore, VDG is ID times RD, that's it. From this, VDG by ID is simply RD, which is your that is your output resistance. And here you can take effective output impedance R0 dash, that is R0 parallel with RD. Okay, this R0 is output impedance at device FET terminals. R0 dash is the output impedance of amplifier. With the biasing resistors, it became amplifier. Okay, so this is the data. Now, what are the points we got? I'm going to placing all these at one point. First, we calculated its input impedance. We got the exact value, that is 1 plus GM into small rd by small rd plus small rd plus capital RD by 1 plus GM into small rd, which is approximately 1 by RD, sorry, 1 by GM. The second one is Ri dash. This is the input impedance of the FET. Input impedance of FET. And Ri dash, which is Ri parallel with Rs. That means 1 by GM parallel with Rs. This is the input impedance of the FET amplifier. Input impedance of amplifier. That is common gate amplifier. Third one is current gain we calculated, AI, which is 1. Fourth one is voltage gain. So the voltage gain exact value is 1 plus GM into small rd into capital RD by small rd plus capital RD, which is approximately GM into small rd parallel with the capital RD, and which is again approximation GM into capital RD. After that, output impedance R naught. R naught is small rd. This is the output impedance of the impedance of FET. Output impedance of FET. Now R naught dash is the RD parallel with capital RD. That means R naught parallel with capital RD. This is the output impedance of amplifier. Of amplifier. Okay, output impedance of amplifier. Okay, output impedance of amplifier. This is the analysis of common gate amplifier. Okay, now we take the same common gate. Instead of using a FET, I am going to using MOSFET. Okay, by using MOSFET, there is a one constraint on MOSFET. MOSFET is acting as an amplifier in saturation region. So using that one as an amplifier, okay, at the same time, by using the proper biasing conditions, you need to operate that should be in saturation region. Okay, now we check all those things. Next, MOSFET common stage. MOSFET. Sorry, default now onwards MOSFET means EMOS. EMOSFET. Enhancement MOSFET. Enhancement MOSFET. Common gate stage. Okay, so default device is N channel. Okay, now I'm going to take the first, it's a circuit diagram, the simplified circuit diagram. Okay, so and this is the source terminal. So this is the simplified common gate stage. It is plus VDD. It is the gate It is the source terminal. Here you are applying input voltage at source terminal. Okay, and here this is the common terminal. So common terminal means you are going to applying proper biasing. So this is the biasing voltage. That VB is the biasing voltage. This is the VDD and it is RD. Okay, so here in this circuit, VB is the biasing voltage. V in is the input voltage or input signal, and we can take output at this point. Taking output at this point. V output is output signal. This is the first level. Okay, now here, for example, in this case what happens is, let us your input signal, whatever the V input we have, there is a small rise in the input. Let us, so I am copying this circuit. See this. Now let us a small rise small rise small rise, that means a small increment, small rises, let us say a small increment at input signal. Let us, I am taking that small rise is delta V. That small rise is delta V. Then what happens? Once the voltage at source is increasing, your VGS can be written as voltage at gate minus voltage at source. You are saying the voltage at source is increasing. Once voltage at source is increasing, VGS is decreasing. Okay, therefore it results. Now gate to source voltage is going to decrease. Gate to source voltage. Okay, decreased by same amount. By same amount. Is decreased by same amount. Once gate to source voltage is decreasing, then your drain current is going to be decreasing. Okay, so then drain current is decreased by, then drain current is decreased by an amount of Gm into delta V. Gm into delta V. Okay, because current is Gm into V. Then once a drain current is, whatever the drain current flowing through this, the drain current is decreasing. Okay, then at the same time your output voltage is going to be, we can write VDD minus ID into RD. Once the drain current is decreasing, output voltage is increasing. Okay, then output voltage is increasing, so it results an increase in output voltage, V output, an increase in V output. Now I am going to writing that equation, how much variation in output. Okay, so your output is now written as, output is GM times delta V, because ID into RD output is into capital RD. This is the variation. Now this is the step-by-step mechanism taking place. Once input is increasing, your output is increasing in this sequence, in this flow. Okay, now is it fine? At the same time, we need to know about how to maintain, what are the conditions to maintain this in saturation region. Okay, now I am going to that. So from this figure we can write voltage at drain, VD is, or V output is VDD minus ID into RD. Okay, now VGS value is voltage at gate minus voltage at source. Okay, now if you take the DC conditions, VGS, voltage at gate terminal, we are applying biasing voltage, minus Vs equal to 0, so which is VB. So now VGS minus VTH is, so this is under DC conditions, is VB minus VTH. Okay, now this is VD or VDS. So therefore, to operate MOSFET in saturation itself, FET in saturation, the condition is VDS should be greater than or equal to VGS minus VTH. Just substitute the values. VDS is nothing but a VDD minus ID, capital ID into RD, which is greater than VGS minus VTH is VB minus VTH. So this is the condition need to maintain. Okay, so by maintaining this condition, you can operate your MOSFET in saturation region. Okay, now here we go and solve one problem. Let us first take the statement of the problem. Now here the problem is a microphone having a DC level of 0, 0 drives a common gate stage biased at ID equal to capital ID equal to 1 milliamp if W by L of that FET is MOSFET is 50 and mu n into COX value is 100 microamps per volt square, comma VTH threshold voltage is 0.5 volts and VDD equal to 1.8 volts. Determine the maximum allowable value of RD and hence the maximum voltage gain So neglect the channel length modulation. Channel length modulation. So neglecting channel length modulation in this sense, take lambda equal to 0. That is the meaning of that. Okay. See, they given all the parameters. ID, W by L, everything they given. Now first from this I am going to calculating the, see this, determine the maximum allowable value of RD. Just before whatever the condition we've written, I am taking that condition. This is our condition. Okay, this is our value. So from this you need to calculate the maximum allowable value of RD, means from this you get the value of RD. Okay, and this is VGS. So we know the ID equation. ID is mu n into COX into W by L into VGS minus VTH whole square by 2. Just substitute the values in this. Mu n COX they given 100 micro by 2 into W by L. W by L is 50. They given ID also 1 milli 10 power minus 3 into VGS value. So we need to measure VGS. You need to calculate VGS. After that you need to substitute this VGS in that condition. Minus VTH they given 0.5 whole square. Just to simplify this. Now this one cancelled in this by 1000 times. 2 zeros and this is 1 0. 3 zeros gets cancelled. Now it is 5 by 2. Okay, it is 2.5. Now here it became 1 by 2.5. Okay, so now I'm going to taking the values, simplifying that. 1 divided by 2.5, it is 0.4. 0.5 whole square. Now it is square root of 0.4. It is 0.632. Square root of 0.4. Taking this square into this side, it is square root 0.632 equal to VGS minus 0.5. Therefore, you get VGS value is 0.5 plus 0.632. That is a 1.132 volts. That is the VGS value. So far we got the VGS value 1.13 volts. Okay. Now determine the maximum allowable value. That means by using that respect to RD value, your device should be operating saturation region. Okay. So now to remain M1 in saturation, M1 in saturation, that means MOSFET saturation. So to remain MOSFET in saturation, our condition is just before you derived that condition. I'm going to that VDD minus ID RD greater than or equal to VB minus